Hello, my name is Daniel, and today we'll be going through the AMC 12B from the year 2014, so let's get started. First problem. Leia has 13 coins, all of which are pennies and nickels. If she had one more nickel than she has now, then she would have the same number of pennies and nickels. In cents, how much are Leia's coins worth? Okay, so since she has 13 coins, so let's say she has 8 pennies and 13 minus 8 nickels, that makes sense. So if she had one more nickels, 14 minus A, this means this same number of pennies and nickels, this equals A, thus A equals 7, and how much are Leia's coins worth? So that's A plus 5 times 13 minus A, which is equal to 7 plus 5 times 6, which is equal to 37, and that's our answer, it's C. Number 2, Orphan went to the store with just enough money to buy 30 balloons. When he arrived, he discovered that the store had a special sale on balloons. Buy one balloon at the regular price and get a second at 1/3 off the regular price. What's the greatest number of balloons Orphan could buy? Okay, so let's say that he went to the store with $30, and let's say that one balloon each costs $1. And then since he gets a second at 1/3 off, that means 1 plus 2/3, this is the amount he has to pay for 2 balloons. That means one balloon, this would cost 5/3 divided by 2 equals $5/6. And so the greatest number of balloons Orphan could buy, that's, he had $30 at the start, right? So it's 30 divided by this number. So that's 5/6, which equals 36. And that is our answer, it's C. Number 3, Randy drove the first third of his trip on a gravel road, the next 20 miles on pavement, and the remaining 1/5 on a dirt road. In miles, how long was Randy's trip? Okay, so since he went 20 miles on pavement, but we have fractions of everything else. So 1 minus the first third minus the last 1/5, this is going to be equal to 20 miles. So this gives us that 7/15 equals 20 miles. So the whole trip must have gone 20 times 15/7, which is equal to 300/7 miles, and that's our answer, it's E. Number 4, Susie pays for 4 muffins and 3 bananas. Calvin spends twice as much paying for 2 muffins and 16 bananas. A muffin is how many times as expensive as a banana? Okay, so 4 muffins and 3 bananas plus 3 bananas equals twice as much paying for 2 muffins and 16 bananas. So that's this divided by 2, so 1 muffin plus 8 bananas. So this gives us that 5 bananas equals 3 muffins. So muffin is 5/3 times as expensive as a banana. That's our answer, it's B. Number 5, Doug constructs a square window using 8 equal-sized panes of glass as shown. The ratio of the height to width for each pane is 5:2, and the borders around them between the panes are 2 inches wide. In inches, what is the solid length of the square window? Okay, so since we know that this is all 2, 2, 2, 2, and 2, and 2, and this is also 2, and this is also 2, and the width and the height to width is 5:2, so we'll say that this is 2a and this is 5a, or this length is 2a and this length is 5a. This gives us that this whole length, that is going to be 10a plus 6, and this whole length, that's going to be 10 plus 8a, right? So 10 plus 8a equals 6 plus 10a. 10 plus 8a equals 6 plus 10a. This gives us 4 equals 2a, a equals 2. And so we want the side length of the square window. You can just put in a value into here. That will give us 10 times 2 plus 6, which is equal to 26. And that's our answer. It's A. Number 6, Ed and Anne both have lemonade with lunch. Ed orders the regular size. Anne gets the large lemonade, which is 50% more than the regular. After both eat 3/4 of their drinks, Anne gives Ed 1/3 of what she has left and 2 additional ounces. When they finish their lemonades, they realize that they both drank the same amount. How many ounces of lemonade did they drink together? Okay, so since we have fractions like 3/4 and like 1/3, so that's 1/3. And so just to be safe, let's say that Ed's regular size has ounces of 24x ounces. And then Anne would have 50% more, so Anne would have 36x ounces. Then, if they both consume 3/4 of their drinks, then they will have 1/4 left. So Ed will have 6x left, and Anne will have 9x left. And then Anne gives Ed 1/3 of what she has left. So this means that Anne gets 6x now, and Ed has 9x now, and 2 additional ounces. So it's 6x minus 2, 9x plus 2. And then they realize that they both drank the same amount. And so we can see that from here to here, Ed drank 18x ounces, and Anne drank 27x ounces from here to here. And so these two plus, so those two added together equals these two added together. And that gives us that's 27x plus 2 equals 33x minus 2. This gives us that 6x equals 4, x equals 2/3. And so how many ounces of lemonade did they drink together? That's just 24 plus 36x. That gives us 60x. Right, so 60x equals 60 times 2/3, which is 40. So they drank 40 ounces, it's D. Number 7, for how many positive integers n is this also a positive integer? Okay, so what this basically means is that the numerator and denominator just have to have a sum of 30. So this is just the same as saying having 30 minus x over x being a positive integer. And so since we can just take that part out, so it's 30 over x being a integer that is greater than 1. So this will mean that x is just the factors of 30 and minus 1, because this is for the 30, because if x is 30, then x will just be 30. That means this is just going to be 0, but it has to be a positive integer, so that goes against the rules. So we have 30 equals 2 first, 3 to the first, 5 to the first. This is 2 to the third power, which is equals 8, and minus 1, so this gives us 7. And that's our answer. It's D. Number 8, in the addition shown below, A, B, C, D are distinct digits. How many different values are possible for D? Okay, so if we see like each column, we see that first of all, ABD, BAD, that just gives us that A plus B equals D, only if there's no carrier. But here we see that B plus C equals B and C plus D equals D. That just gives us that C is 0, and there's just not going to be any carry over here, right? So A plus B equals D, and so for the possible values of that, if A is 1, then B can be all the way from 2 to 7, and then D is going to be all the way from 3 to 8. And since they are distinct digits, and if A is 4, then B can be 5, this gives us 9. So this is 6 values plus 1 more, this gives us 7 values in total, and that's our answer, it's C. Number 9, convex quadrilateral ABCD has AB equals 3, BC equals 4, CD equals 13, and AD equals 12, and ABC equals 90 degrees, as shown was the area of the quadrilateral. Okay, so this diagram is just like begging us to draw this line from AC. And so by the Pythagorean theorem, we see that this length is 5, and by the Pythagorean theorem, we see that this is a right angle, and so the area is going to be just this area plus that area, which is going to be 3 times 4 times 1/2, which is 6, plus and the 5 times 12 times 1/2, which is 30. So this is going to be 36, and that's our answer, it's B. Number 10, Danica drove her new car on a trip for a whole number of hours, averaging 55 miles per hour. At the beginning of the trip, ABC miles was displayed on the odometer, where ABC is a 3-digit number with A is greater than or equal to 1, and A plus B plus C is less than or equal to 7. At the end of the trip, the odometer showed CBA miles, which is A squared plus B squared plus C squared. Okay, so first it was ABC, and then at last it became CBA, and so that means that the distance traveled is CBA minus ABC. So that would be 100C plus 10B plus A minus 100A plus 10B plus C. This is going to be 99C minus 99A, and this has to be a multiple of 55 because she went for a whole number of hours, with 55 miles per hour. 55 multiple. This means that just C minus A must be equal to 5, and since A plus B plus C is less than or equal to 7, that must mean that C is 6 and A is 1, because there's no other explanation since A has to be greater than or equal to 1. And so this just gives us that B equals 0, and so A squared plus B squared plus C squared, this is going to equal 1 squared plus 0 squared plus 6 squared equals 37, and that is our answer, it's D. Number 11, a list of 11 positive integers has a mean of 10, a median of 9, and a unique mode of 8. What is the largest possible value of an integer in the list? Okay, so our 11 positive integers are going to be like this, like that, right? And so we will have our median in the middle, so that's going to be 9. And we have a unique mode of 8, so we will need to have as many 8s as possible while keeping this the largest, right? So that's kind of, we don't know that really, so let's jump to the mean first. Since 11 integers has a mean of 10, that means the total has to be 110 integers. So this much is total of 110 integers. This gives us that we need 3 8s, and 2 9s, and 10 and 2 10s, and 2 1s, because we need the greatest possible value of that one. And so we would have 11 over here, and if we could get that, that would be equal to 110 total, right? 110 minus, and then this would be 10, this would be 10, 20, and then 30, 40, and then 40 plus 24, that's going to be 64, 64 plus 11, that's going to be 75, this is going to be equal to 35, and 35 is our answer, it's E, and that's also the largest answer choice, so that must be the answer. Number 12, a set S consists of triangles whose sides have integer lengths less than 5, and no two elements of S are congruent or similar. What is the largest number of elements that S can have? And this is basically all casework, but we can divide some categories. First of all, we can only have one equilateral. That's just going to be one, right? Either it's just 1, 1, 1, or it's 2, 2, 2, or it's 3, 3, 3, or it's 4, 4, 4. It's all going to be similar. So no two elements of S can be similar. That's why we can have only one equilateral. But for isosceles, the matter is different, and so there are a lot of possible isosceles, and so you will see that there can be 2, 2, 1 like that, or there can be 3, 3, 1, or 4, 4, 1, right? They're all not similar, and we can have 3, 3, 2. We can't have 4, 4, 2 because that would be overlapping with that one, and so now we can have 2, 2, 3, and we can have 4, 4, 3, and we can have 3, 3, 4, and that's basically it for isosceles. And lastly, we have scalene triangles. And if you've forgotten what scalene is, that's just all three being different lengths. So we have only one triangle for that. That's going to be the 1, 2, 3, and 4. And so summing all of those together, those are 9 elements. So that's the largest number. It's the answer. It's B. Number 13, real numbers A and B are chosen with this, such as that no triangle with positive area has side length 1, A and B, or 1 over B, 1 over A and 1. What is the smallest possible value of B? Okay, so since we have this inequality, we see that which of these is the largest. That's going to be B. So that means that 1 plus A is less than or equal to B. And for this one, we can see that 1 is the largest because A and B are both greater than 1. And it's going to be their reciprocal. So that means that 1 over A plus 1 over B is less than or equal to 1. And so from this, we can gain that A is less than or equal to B minus 1. And if we cross multiply that, then we can get that A plus B is less than or equal to AB. And from here, we can see that B is less than or equal to A times B minus 1, because A is going to go over there. And using this, we can plug that into this A here to get this is less than or equal to B minus 1 squared. So this gives us that B is less than or equal to B minus B squared minus 2B plus 1. So this gives us that B squared minus 3B plus 1 is greater than or equal to 0. And so if we perfect square this, then that's going to be B minus 3 over 2 squared minus 5 over 4. This is greater than or equal to 0. And the smallest possible value of B, that would occur when B is equal to, that would occur when B is equal to 3 over 2, and then this has to be satisfied, and so we have to do plus 5 over 4, and then put a root on that. So this is going to be equal to 3 plus root 5 over 2, and that is our answer, so it's C. Number 14, a rectangular box has a total surface area of 94 square inches. The sum of the length of all its edges is 48 inches. Where's the sum of the length in inches of all its interior diagonals? Okay, so imagine a rectangular box like that. So let's say that this lengths, they are A, B, and C respectively. And so since the surface area is 94 square inches, that means that 2AB plus 2BC plus 2CA, this is going to be equal to 94. And there is a reason that I'm not going to divide that by 2. And next, the sum of the length of all its edges is 48 inches. That means we have 4 of A's, 4 B's, 4 C's. That add up to 48. So this gives us that A plus B plus C equals 48 divided by 4, which is 12. And so now we can do A plus B plus C squared, which equals A squared plus B squared plus C squared plus 2AB plus 2BC plus 2CA. And now you realize why I just kept this as it was and not divided it by 2. So this is just going to all become 94, and this is going to become 12 squared. So it's going to become 12 squared, which is 144, equals A squared plus B squared plus C squared plus 94. Therefore, A squared plus B squared plus C squared must equal 50, and the sum of all its interior diagonals, that's just all going to be 4 times, because we have 4 interior diagonals, like that. So that's going to be 4 times, and then root A squared plus B squared plus C squared. And we just have what we want right here. And so this is going to be equal to 4 root 50, which equals 4 times 5 root 2, which equals 4 times 5 root 2, which is 20 root 2. So 20 root 2 is our answer. It's D. Number 15, when P is the summation of K equals 1 to 6 of K, L, and K, the number e to the pth power is an integer. What is the largest power of 2? That is a factor of e to the pth power. Okay, so if we just put in the values 1 to 6 in K, L, and K, that's just going to mean P is going to be the ln of, then 1 to the first power times 2 to the second power times 3 to the third power times 4 to the fourth power times 5 to the fifth power times 6 to the sixth power. And so if we do e to the pth power, then we're going to raise this to e like that. And so e and ln, this is going to cancel. So this is going to leave us with this thing, right? So 1 is the first, 2 to the second, 3 to the third, 4 to the fourth, 5 to the fifth, 6 to the sixth, and this is going to be just equal to, this can go away, this is 2 squared, 3 cubed, and then 2 to the 8th power times 5 to the 5th power times 2 to the 6th power, 3 to the 6th power. And we want the largest power of 2, that is the factor of this thing, and so we can just take out just 2, 8, 6, and then just add them all up. That's going to be 16, and so this is 2 to the 16th power, and there is our answer. It's C. Number 16, let P be a cubic polynomial with P0 equals K, P1 equals 2K, and P minus 1 equals 3K. What is P2 plus P negative 2? Okay, so since we know that it's a cubic polynomial and P0 is K, right, then we are going to have something like ax cubed plus bx squared plus cx, and then we're going to have plus K because it said that P0 equals K. Since P1 equals 2K, if we put 1 in here, then that's going to give us A plus B plus C equals K. And P negative 1, that's going to give us the same thing. No, not the same thing. That's going to give us minus A plus B minus C. This equals 2K. And so if we add these up together, then that's going to mean that 2B is equal to 3K. So B equals 3 over 2K. And we want P2 plus P of minus 2. So if we do that, then we are going to find that the A's and C's, they cancel because these are odd exponents. So if they are multiplied by some number and it's negative number, then it's going to just go away. So this gives us that it's B times 4 plus B times 4 plus K. Right, that's going to be 8B plus K. Since B is this, we can just put that in. This is equal to, this is plus 2K because we have K for each one of these. So it's 8B plus 2K, which is 12K plus 2K, equals 14K. And that's the answer, and I hope that was okay. Number 17, let P be the parabola with equation y equals x squared, and let Q equal 20, 14. There are real numbers R and S such that the line through Q with slope n does not intersect P if and only if M is between R and S. What is R plus S? Okay, so basically what we want here is for it to not intersect P. And these are like just the boundaries of would be intersecting and not intersecting. So this is just basically asking for the tangent line slopes. We are going to kind of use calculus here. This is calculus based. And if you don't know calculus, I'll just give you a quick explanation of calculating polynomials. So basically, if you have x to the 8th power, then you take the derivative of it. Then this is just going to be a x to the a minus 1 power, right? So it's just like this is just coming down, and then since 1 came down, it's going to be decreasing by 1. And so same thing with x squared. This is going to be when taken its derivative, that's going to be the 2 is going to come down, like, 2, and then x to the 2 minus 1, so that's going to be 1, right? If we have just constant numbers, if we take their derivative, these are weak, so they just get 0. But there is a way for this to survive. It's when this is tacked onto an x as a coefficient, right? So if we have like 2x squared and we take its derivative, then it's going to be 2 times and then just this derivative, right? So 2 times x squared derivative, that's going to be 2x. But the only derivatives that we're going to be using here is that of x squared. And we just saw that, x squared, so its derivative is 2x. And that's the slope of its tangent line. So that's the slope of a line. So that's going to be 2x. That equals x squared minus 14 over x minus 20. This is just rise over run using just x comma x squared and 20 comma 14. So that will give us that 2x squared minus 40x equals x squared minus 14. And so that means that x squared minus 40x plus 14 equals 0. And so this gives us that x squared minus 40x plus 400, that equals 386, meaning that x minus 20 squared equals 386. So that gives us that x equals 20 plus or minus root 386. So that means that our tangent line is 2x, so the slopes are 2x. 2x is going to be 40 plus or minus 2 root 386. And so we want the sum of the tangent line slopes. So the sum is going to, these two are going to cancel out because there's a plus and there's a minus, so it's going to be 80. And that's our answer, it's E. Number 18, the numbers 1, 2, 3, 4, and 5 are to be arranged in a circle. An arrangement is bad if it's not true that for every n from 1 to 15, one can find a subset of the numbers that appear consecutively on the circle that sum to n. Arrangements that differ only by a rotation or a reflection are considered the same. How many different bad arrangements are there? Okay, so we have the numbers 1, 2, 3, 4, 5, and then we have to find numbers from 1 to 15. So that's going to be 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 14, and then 15, like that, right? First of all, we just see that in any combination, we must get these 5 numbers because that's when you just count one by one. And also, you must get these 5 numbers because that's just taking everything except 1. And then this must also be in there because that's just taking everything. And so our only hope is to, our only hope for bad arrangements are for it to be impossible to get 6, 7, 8, or 9 as a sum. But then even here, we see that 7 and 8 being impossible are the same thing as 6 and 9 being impossible. Since the whole sum is 15, that means if we don't have a 6, then we don't have a 9. But if we do have a 6, then we do have a 9 because we can just sum the numbers that were not in the previous sum, and that will get us with the other number. So that means our maximum is 2, so we can just cross out all of these. So first of all, let's try to, so our maximum is 2, and let's try to make something with no 6s possible. If we have no 6, then that's going to be like 1, 2, and then I can't put 3 here because this is going to make a 3, and I can't put 4 here because this is going to make a 6, so I'm just going to put a 5, and then I can't put like so I can put a 5 there, so I'm just going to make a 4 and a 3, because if I put a 3 there, then this is going to be 6, right? So this is possible. And for no 7, then first of all, 1 and 2 together, that's a disaster, because if we have 5, then it doesn't work. If we have 4, then this is going to be 7, and if we have 3, then we're going to have on this side 4, and that's going to make 7, or we're going to have this side 4, and that's going to make 7. So the only choice we have is to not have 2 there, and have 5 here, and 4 here, and then 2 here, and then 3 here, and that is impossible to make a 7. So we have both of those cases, so that is our maximum. So this is 2, and that's our answer. It's B. Number 19. A sphere is inscribed in a truncated right circular cone as shown. The volume of the truncated cone is twice that of the sphere. What's the ratio of the radius of the bottom base of the truncated cone to the radius of the top base of the truncated cone? Okay, so basically what it wants us to get is the ratio of this to this. And so now we are going to imagine like this truncated cone not being truncated at all, right? So it's going to be back to its former glory like that. And then we are going to kind of press it forward from a 3D shape into a 2D shape. And so what we're going to do is we're going to press this forward into a 2D shape, and it's going to become flat. And then it's going to become something like this. It's going to become something like that. And then this, and then this thing that will be over here. So that's going to look something like that. And then this is going to be the radius of the circle, and let me draw that a little better. So that's going to look something like that, right? In this branch, that's just me showing off a radius. And so let's say that this radius of the sphere, let's call that S, and let's call the small radius R, and the big radius large R, like that. And then let's call this height H. So this is S, and now we're all set to go. Because by this line, we can see that if we separate it like that, like this, then we see that this and this length is the same, and we can see that this and this length is the same. So this is R and this is R, so that gives us, it's R plus R. So that gives us that if we just draw a line from here, right here to right over there, like that, then we can see that we will have a right triangle over here, and the base, that's going to be large R minus small r, so that's going to be R minus R, and this is going to be 2s. So we can get that big R plus small r, so big R plus small r squared equals 4s squared, that's this squared, plus big R minus small r squared. And so that's going to be 4rr equals 4s squared, so rr equals s squared. So that's our first thing. Big R times small r equals s squared. And then our next thing is we are going to compare this one and this one, because they are also similar. And so that means that the ratio of h to r is going to be equal to the ratio of 2s to r minus r. So this gives us that r over h, that is r over h, is equal to this over that, which is r minus r over 2s. And so if we cross multiply, that gives us that 2rs equals r minus r times h. And so let me write that again. r minus r times h equals 2rs. Okay, and now let's proceed with our calculations. And so now we can use this condition that the volume of the truncated cone is twice that of the sphere. So if we get the volume of the truncated cone, then that's going to be this whole thing minus this upper thing. So that's going to be 1 over 3 times, and then r squared times 2s plus h, minus small r squared times h. So this is going to be equal to and then 4 over 3 times pi r squared, and r is just s, so pi times s cubed, and then times 2, because the volume is twice that of the sphere, and so if we multiply 3 to each side, then this is going to give us that r squared. Yeah, this is going to give us that r squared. 2s plus h minus r squared h is going to give us 4 times 2, so that's 8. So that gives us 8, so it's 8 pi s cubed. Sorry, I have to multiply pi to here because this is a cone. Yeah, and then we can take out this pi. And so that's going to give us, yeah, that's going to give us r squared times 2s plus h minus r squared h equals 8s cubed. 8s cubed. Now we can say that this is going to be, yeah, just 2r squared s plus r squared h minus hr squared. This is going to be equal to 8s cubed. I've just got rid of those parentheses. And now in this, we can see that it's 2r squared s plus and then h times r squared minus r squared. So it's r minus r times r plus r, right? And then this is going to be equal to 8s cubed. But then now we see this condition. R minus r times h equals 2rs. So this equals 2rs. So 2r squared s plus 2rs times r plus r. Yeah, times r plus r. This is going to be equal to 8s cubed. And dividing everything by 2s, we can get that r squared plus r plus r squared. This equals 4s squared, right? So this equals 4s squared. And we know that big R small r equals s squared. So if we just change that s squared into r, that gives us that r squared plus r plus small r squared equals 4r. And if we make that go over there, then that's going to give us r squared minus 3r plus r squared. This is going to be equal to 0. And now if we use the quadratic formula on this, then that's going to give us that 3 minus root 5 over 2 is equal to small r over big R. So since this is the case, and what we want is big R over small r, then this is going to be equal to 2 over 3 minus root 5. And this is going to be equal to all over 4, 2 times 3 plus root 5, which is equal to 3 plus root 5 over 2. And this is the answer, so it's E. Number 20, for how many positive integers x is log 10 of x minus 40 plus log 10 of 60 minus x is less than 2? And if we just add logs of the same base, then we can just multiply those together. And so log of x minus 40 times 60 minus x is less than 2. And so that will give us that either x minus 40 times 60 minus x is less than 100. And therefore, x squared, so minus x squared plus 100x minus 2500 is less than 0. And so this gives us that x squared minus 100x plus 2500 is greater than 0. This gives us that x minus 50 squared is greater than 0. This means x just must not be 50. X is not 50, then we're all fine. Since these both, they must be greater than 0, that means this has to be greater than 0. This gives us that, yeah, because of this, right, x minus 40 has to be greater than 0, so x has to be greater than 40, and this gives us that this has to be defined, so x has to be less than 60, and if we just put this in the middle, this just gives us that 40, x, 60 like that, but x is not 50. This gives us that we have 18 integers, and that is our answer. It's 18, it's B. Number 21. In the figure, ABCD is a square of side length 1. The rectangles JKHG and EBCF are congruent. What is BE? Okay, so we know that this has side length 1, so this is going to be 1. And then let's say that BE, this is A. A, that's the length that we want to get. And then let's say that we have, yeah, this is also 1, right? Because this and this are congruent. And this is also A. And now let's say that for this one, we have M. Yeah, we have M and N. Those are going to be the ratios. And since this is similar to that, yeah, so since this and this is similar, we see that this must be AM and this must be AN. So this is AM, this is AN, like that. And then we have the same thing for here, because these two are equal and these two are equal. And so that will just give us, we have AN here and AM here and A over here. So that gives us that this is also A, so adding all of that together is equal to 1. So A plus M plus AN equals 1. For this part, AM plus N, that is also equal to 1. So now we can get that A equals 1 minus N over M equals 1 minus M over N plus 1. This is taken from here, and this is taken from this one. So this gives us that if we cross multiply, this is going to be difference of squares, so that's going to be 1 minus N squared equals m minus m squared. So this gives us that m squared minus n squared equals m minus 1. And we know that m squared, that is just equal to 2m squared minus m squared, like that. And then we can just do minus n squared equals m minus 1. But then now that goes to 1, because from this triangle, that's a right triangle, we see that m squared plus n squared equals 1, because this is a right triangle, so this holds true. Therefore, this must be 2m squared minus 1 equals m minus 1. So let's write that again. 2m squared minus 1 equals m minus 1. These two can cancel. 2m equals 1. Therefore, m is going to be equal to 1 over 2. Since m is equal to 1 over 2, this gives us that n is equal to root 3 over 2. And so we can plug this into this equation to get a. So a times 1 over 2, so half a plus n, which is root 3 over 2. This is going to be equal to 1. So a is equal to 2 minus root 3, and that is basically our answer. That's C. Number 22. In a small pond, there are 11 lily pads in a row, labeled 0 through 10. A frog is sitting on pad 1. When the frog is on pad n, with n between 0 and 10, it will jump to pad n minus 1 with probability n over 10, and to pad n plus 1 with probability 1 minus n over 10. Each jump is independent of the previous jumps. If the frog reaches pad 0, it will be eaten by a patiently waiting snake. If the frog reaches pad 10, it will exit the pond, never to return. What is the probability that the frog will escape without being eaten by the snake? Okay, so first thing that we have to notice is that we have 11 lily pads like that. And then we have lily pad number 5. And if we go on to lily pad number 5, then it jumping to the next one is 1 over 2. And jumping to the previous one, that's 1 over 2. That just means that its chances of surviving on pad 5 are exactly half, and its chances of dying also exactly half. And so that means that we can just consider all of the probabilities until the 5th lily pad, and then we can just say that is equal to 1/2, and then be done with it. And so let's say that the first lily pads from 1, 2, 3, 4, 5, that's going to be pad A, B, C, D, and E. So those are going to be the names of the pads. And it will jump to pad n minus 1 with probability n over 10, and n plus 1 with 1 minus n over 10. So its probability of surviving is 1 minus n over 10 times the probability that will survive in the next lily pad times the probability that it will jump to pad n minus 1 and survive there. So this is just going to give us 9 over 10 times p, because we just can't go back to the pad 0 because that's going to be like 0 probability of surviving. And then b, this is going to be equal to 2 over 10 times a plus 8 over 10 times c. This is exactly for the reason that I just said before. This is the probability that it goes back, and this is the probability that he survives. And this is the probability that he goes forward, and this is the probability that it survives there. So that's going to be our probability for b. And same thing, c, that's going to be equal to 3 over 10 b plus 7 over 10 d. D is going to be equal to 4 over 10 c plus 6 over 10 e. And e, as we said before, this is just going to be equal to 1/2, because this is the 5th lily pad. And so with this one, we can just put in many equations. So first of all, we know that e is equal to 1/2, so if we just put that in, d equals 4 over 10c plus 3 over 10. So this gives us 10d equals 4c plus 3, and we know that 10c equals 3b plus 7d. That's from this thing. If we multiply 10 to both sides, is what we're going to get. If we multiply that by 10, it's going to be 100c equals 30b plus 70d. And the reason we did this is to put this inside. And so if we do that, then we're going to get something called 100c equals 30b plus 7 times 10d, which is 4c plus 3. 4c plus 3. So that's going to give us 72c, because 100 minus 28, that's 72c, equals 30b plus 21. And if we divide by 3, that's going to give us 24c equals 10b plus 7. And then, since we know about 10b is going to be equal to, from that 10b is going to be equal to 2a plus 8c. And if we multiply that by 3, 30b, that's going to be equal to 6a plus 24c. Since we know what 24c is, we can just put that in. So this equals 30b equals 6a plus, and then 10b plus c. That's going to give us that 20b equals 6a plus 7. A is equal to 9 over 10b, right? And this is also equal to, since b is just this divided by 20, so let's just do that. 9 over 10 times, and then 6a plus 7 over 20. So multiplying 200 to both sides, we get that 200a equals 54a plus 63. Therefore, 146a equals 63, and a is going to be thus equal to 63 over 146, and that is our final answer. It's C. Number 23, the number 2017 is prime. Let S equal the summation from k equals 0 to 62 of 2014. Choose k. This is basically equal to 2014 ck, and for those of you who didn't know, this is just choosing k out of 2014 without not caring for order. What is the remainder when S is divided by 2017? Okay, so first thing that we have to notice is since 2017 is prime, we can't just prime factorize it because that's just 1 times 2017. And so 2017, this is just equal to minus 3 mod 2017. So this gives us that 2014 choose k. I'll just write it like this. 2014 choose k. This is going to be equal, this is going to be congruent to, because we're dealing with mods, it's going to be 2014 times 2013 is decreasing, 2012, 2011, all the way up to 2014 minus k plus 1. This is because this is the kth number, all the way, all over k factorial. And this mod 2017. So this is going to be congruent to, and then 2014 is equal to minus 3 mod 2017. Therefore, this is going to be equal to minus 4 mod 2017. This is going to be minus 5 mod 2017, and so on. So it's going to be minus 3 times minus 4 times minus 5, all the way up to, and then minus 2017 of that. So that's going to be minus k minus 2, all over k factorial as before. K factorial, like that, mod 2017. So this is going to be congruent to, and then we can just take out all the negative signs, right? Take out all the negative signs and then just put them all in one place. So this is k integers, so this is minus 1 to the kth power times, and then all of k factorial under 3 times 4 times 5 times all the way up to k plus 2. So this is going to be mod of 2017. And we know what this is, so we see that this much is k numbers, and this is k factorial, so we can just say that this is congruent to minus 1 to the k times, and this is just going to be k plus 2 choose k. So times k plus 2 choose k. And then mod 2017, of course. Mod 2017. But then since we just know that that is just equal to k plus 2 choose 2 mod 2017, and we also know that this is just equal to 1 plus 2 plus 3 plus all the way up to k plus 1, then this is going to be equal to, this is going to be congruent to minus 1 to the kth power times 1 plus 2 plus 3 plus all the way to k plus 1, like that. And then now if we just sum it all from k's from 0 to 62, and then now if we sum from k is equal to 0 to 62, that's going to give us, this is going to be equal to 1, and then minus 1 plus 2, plus 1 plus 2 plus 3, and then minus 1 plus 2 plus 3 plus 4, and then plus 1 plus 2 plus 3 plus 4 plus 5, plus 5, and then all the way up to plus 1 plus 2 plus all the way up to 63, like that. And you see what's happening here. If we pair it off like that, these two are going to get cancelled by that. This 4 is going to get cancelled by that, and so what we're left with is essentially 1 plus 3 plus 5 plus all the way up to 63. And this is just the sum of all odd numbers, and we have 32 numbers like that. So this is basically going to be equal to 32 squared, and then we still have to put them on 2017. And we know that 32 squared is equal to 1024, so it's 1024 mod 2014, mod 2014, and finally there we have our answer, so that's going to be C. Number 24, let ABCDE be a pentagon inscribed in a circle such that AB equals CD equals 3, BC equals DE equals 10, and AE equals 14. The sum of the lengths of all diagonals of ABCDE is equal to m over n, where m and n are relatively prime positive integers. Where's m plus n? Okay, so first if we just bring out a diagram here, so the green one is the pentagon and the black one is the circle. So let's say that this is going to be A, B, C, D, and E, like that. So AB equals CD equals 3, so this is 3, this is 3, and BC equals DE equals 10, this is 10, and this is 10, like that. And if you connect lines to C, and if you connect line from C up to E like that, then we can see that these two are congruent. So they are congruent, and so that just means that this and this are equal. So that means AC and CE is equal, AC equals CE. And now if we draw all the other diagonals, then we're going to have BD like that. One more thing, we see that this is also congruent to this thing. So ABC and BCD, they are congruent. That means that this and this are also equal. So AC equals CE also equals BD. BD, let's just call this A. And then next is BE. This is equal to B. And then BE is equal to B. And then AD, we'll just draw that in, but we'll deal with that later. We don't really need a name for it right now. Okay, so now we are going to use Ptolemy's theorem multiple times. So it's called Ptolemy's theorem. And Ptolemy was a famous mathematician from like ancient times, right? And what he basically said was that if you have a circle and if you have a quadrilateral inscribed inside it, so basically if you have a cyclic quadrilateral, then this times this plus this times this is going to be equal to this times this. So he basically said that the multiple of the diagonals, so the product of the diagonals, is going to be equal to the product of these two plus the product of these two. And that's what we're going to use here. First of all, if we use Ptolemy on, I'll just say PTOL, on ABCE. So that's going to be AB and then CE, right? This one over here. So these are going to be our diagonals. And so what do we say? AB times CE plus BC times AE equals BE times AC. And remember that we had A and B for those things. And so this gives us that AC times BE, so that's going to be A times B. This is going to be equal to, sorry, we didn't say that A equals 14, so this is 14 right there. So this is going to be equal to 10 times 14, that's 140, plus 3 times CE, CE is A, that's 3A. So this gives us that B is just going to be equal to 140 plus 3A over A, which is basically just 140 over A plus 3. And then next we're going to use Ptolemy on BCDE. And if you see BCD is this one right here, that one right there, and our diagonals are going to be these two. It's going to be CE and BD. So CE times BD, that's just going to be A squared. So A squared is going to be equal to, and then 10 times 10 plus 3 times 14. Sorry, 3 times BE. And so that's going to be 100 plus 3 times B, 3B. And now since B equals this, we can just substitute that in. So A squared equals 100 plus 3 times 140 over A plus 3. And so A squared is equal to 109 plus 3 times 140 over A. So 3 times 140 over A. If we just multiply by A, then we're going to get that A cubed minus 109A minus 420 is going to be equal to 0. This gives that it's A plus 5 times A plus 7 times A minus 12. This equals 0. And so this just gives us that A is equal to 12 because A is a length, so it can't be negative. So A equals 12, and by that we see that B is equal to 140 over 12 plus 3, which is just 44 over 3. So those are our values of A and B, and now we can get to getting the value of AD. So what we do now is do Ptolemy on ABDE. So that's going to look something like ABDE, so that's going to be this one, and we're going to have BE and AD as our diagonals. Then we can see that it's AD times BE, which is just B. This is going to be equal to 14 times A, so 14A plus, and then 3 times 10, that's 30. So that means AD is going to be equal to 14A plus 30 over B. And we know what A is, we know what B is, then we can just plug them in. So this is going to be equal to all over 44 over 3. The numerator is going to be 14 times 12 plus 30, which is just going to be 14 times 12 times 30. That's times, and so this is going to be all over 44. 3 times 14 times 12 times 30. So this is going to be all over 44 over 594. Sorry, this is plus 30. And so this is going to be 594 over 44, which is just equal to 27 over 2. So there we have our AD, and we want m plus n. So the sum of length of all diagonals. So that's going to look something like 3 of A's and 1 B and 1 27 over 2. 3A plus B plus 27 over 2. That's going to be equal to 36 plus 44 over 3 plus 27 over 2. And that is going to be equal to 385 over 6. And now what we must do is do 385 plus 6, and that is going to come out as equal to 391. And that is our answer, so it's D. Problem number 25. Find the sum of all the positive solutions for this monstrosity. Yay! So the first thing that we're going to do here is just convert that into something we can use easier, 2 cosine squared of 2x minus 2. Now what we can do is, there's so many cosine of 2x, so we can set cosine 2x as equal to a. Then that means that we just leave this alone. So we'll just do that too. Cosine of 2014 pi squared over x equals b. So substituting in all the values, so all those values for a and b, that's going to give us 2a times a minus b equals, and then using that, it's going to be 2a squared minus 2. So since we can just take out the 2a squared, this gives us that minus 2ab equals minus 2. So that means ab equals 1. And if ab equals 1 and we want positive solutions, that means a is 1 and b is 1, or a is minus 1 and b is minus 1. So if a is 1 and b is 1, then this is basically going to give us that this has to be 1. So that means x has to be something k pi, where k is an integer. So that's just going to basically give us a cosine of 2x. If we just put this into here, so that means b is going to be 2014 pi squared over k pi, right? And so this is going to be 2014 over k times pi, and this is going to be equal to b is 1. So that means this must be an even multiple of 2 pi. Even multiple of 2 pi. And that means this must be even. That means k must be an odd divisor of 2014. And that is because 2014, this is only 2 times 19 times 53. So if k is even, then that's just going to be an odd number. So k has to be an odd divisor of 2014. So that means by these, then k can be equal to 1, 19, 53, or their multiple, 1007. So that means that x is going to be equal to pi, 19 pi, 53 pi, and 1007 pi, because x is just k pi. And now let's look at this case where a is negative 1 and b is also negative 1. So this gives us that cosine 2 of x is negative 1. This just means that x has to be, so this means that cosine, this has to be an odd multiple of pi. So that means x is m over 2 pi, and m must be an odd integer. That's the only way for this to be minus 1. This has to be minus 1 also, and if we put this x value into here, then what we're going to get is that it's 2014 minus x all over m over 2 pi. So, but then this must also be an odd multiple of x. Sorry, odd multiple of pi. And so for that, sorry, it's not 2014 minus x, that's 2014 pi squared. And then so that means this thing, that must be an odd number. So m under 4028, this must be an odd number. This means that m must be a multiple of 4, which is even. And so this says that m must be odd, this says that m must be even, so there is a contradiction. And so that means that this is just impossible. So we can just concern ourselves with these values, and the sum of those values are going to be our answer. So if we take the sum of these, 1 plus 19 plus 53 plus 1007 times pi, this is going to be equal to 1080 pi, and that is our answer. It's D. So that was it for the AMC 12B from the year 2014, and thank you for watching.